Hi, this is Barrett Givens, and in this video, we're going to talk about the subspace topology. So the idea of the subspace topology is that you have a topological space X, and that's your universe. And we want to shrink X to a smaller universe, Y. So we're going to go down to a subset Y of X, and we're going to think of that as a new topological space. So we're sort of shrinking our universe. And so our smaller universe will have a topology that it inherits from X called the subspace topology. And basically, the subspace topology on Y consists of all sets of the form U intersect Y, where U is open in X. So I think of open in Y as being anything of the form Y intersected with a set which is open in X. And it's not too hard to show. You can sort of see this, that closed in Y would mean Y intersect closed in X. This is just a shorthand. And a basic open set in Y would look like Y intersect with a basic open set in X. So you think about X, you think about what kinds of open and closed and basic open sets you have in X, and then you imagine what would happen when those are intersected with your smaller universe. And whatever you get, those are the basic open sets or the open sets or the closed sets in your subspace topology, in your new smaller universe. Let's look at a couple of examples. All right, so for the first example, we're going to let X be the real numbers, and we'll let Y be the closed interval from 0 to 1. So X will be the real numbers, and Y will be the closed interval from 0 to 1. So this is my Y. And the basic open subsets on the reals in the standard topology are open intervals of the form A comma B, open intervals. And I want to think about what happens when I take an open interval and I intersect it with this Y. So take an open interval and intersect it with this Y. Well, there's a number of different things that could happen. One thing that can happen is that I could have an open interval, which is just inside of Y like that. When I intersect that kind of an interval with Y, I just get the interval itself. So that could happen. Another thing that could happen is I could take an open interval that sort of overlaps with Y, but has part outside and part inside. And I could do that either at the bottom end of Y or at the top end of Y. So what do I get when I do that? When I intersect an open interval like this with Y, what I get is I get the part from 0 to the top end like that, and it includes 0. Or at the other end, I'd get something that goes from some number up to 1, including 1. And so the basic open subsets in the subspace topology on 0, 1 as a subset of the reals with the standard topology have the form. Well, there's 3 possible types. One type is they can look like 0A, where A is some number between 0 and 1. Or they could look like B comma 1, including 1, where B is some number between 0 and 1. Or they could look like A comma B, where A and B are both between 0 and 1. Okay. So it's sort of interesting because the basic open subsets in this subspace topology, they don't necessarily look open. Like some of these sort of seem like they're not open because they have a closed interval at one end. But the idea is that my universe sort of has this wall right there at 0. And so the basic open sets, when they hit that wall, they just kind of like stop there and they can include that point. Okay. So the basic open subsets on Y look like open intervals, or if they go all the way out to the edge of Y, to the edge of our new universe, then they would include that endpoint of our new universe, either 0 or 1 at either end. Okay, so that is the basic open subsets in the subspace topology on 0, 1 as a subspace of the reals with the standard topology. All right, here's a second example. Let's let X be R2, and we'll let Y be S1, which is the name that we're going to use for the unit circle. So my R or sorry, my X is R2, and my subspace is the unit circle. This is my S1. S1 stands for unit circle. So what do the basic open subsets look like in R2? The basic open subsets in R2 look like open balls. So the basic open subsets look sort of like this. When I intersect that open ball with the unit circle, what do I get is I get just the little bit between this little bit that's in on the circle and inside of that ball. And it would not include the endpoints because the ball's boundary is not included. Or if I draw another ball over here, maybe something like really large one, the intersection of that ball with the unit circle would be this part of the circle. Okay. And so in this case, on the circle as a subspace of R2, the topology looks like sort of these open arcs. Another way to think about it is like they're open intervals of angles. Okay, these are the basic open sets. So it's almost like you've just taken the real line and like curved it around and connected its endpoints in a way, okay? Because they look a lot like open intervals on the reals. They're just open intervals on a curved a curve. All right. So those are two very well-known examples of subspace topologies that we're going to be coming back to quite frequently. And so you definitely want to study those and make sure to like think about them and why they work the way they do. All right. Thank you for listening.